Hello, everyone, and welcome to our Senceive May webinar. This month, we're talking all about satellite communications for wireless monitoring in remote locations. I'm Jackie Jenkin, Marketing Manager at Senceive. We're really excited to share all the details about our SATCOMs option. We launched this just last month, and it's certainly a significant enhancement option to our GeoWAN platform. Today we have Adam Fiddler here with us. He's our speaker. He's been an embedded software engineer at Senceive for the past 3 years, and he's played a crucial role in the launch of this product. So he's definitely the ideal expert to guide you through how to apply a SATCOM solution to your next remote monitoring project. As we go along, please feel free to submit any questions you have in the question box. It should be a panel on the side of your screen, and we're going to try to get to all the questions at the end if it's possible. So thank you so much, Adam, and leave it over to you.
Excellent. Thanks so much, Jackie. And greetings to all of our attendees. Thanks for joining today. Looking forward to taking you through our SATCOM solution. To kick things off, how I fit into the puzzle. I studied and grew up in South Africa, did a degree in electronic engineering. I spent 4 years working for a company designing monitoring equipment for conveyor belts in the mining industry. Moved into a different company that was designing people and vehicle detection systems, predominantly around shopping centers, retail statistics, airports, those kind of areas. And in 2021, made the move to the UK and joined the Senceive team as an embedded software engineer. And since then, my team has been involved on a lot of improvements to the existing product family, as well as the launch of our digital interface node and this SATCOM solution. So what we're going to cover today is firstly, why satellite communications is relevant, especially in our industry, the components that make up a satellite communications solution. We're going to go through an exercise of scoping a SATCOMs monitoring project where you'll learn the relevant information that we need to make that project a reality. Discuss accessing your data, and then also have a brief review on a SATCOMs project that is currently live on one of our customer sites. So to kick things off, why SATCOMs? What is the problem that we're solving and why is it relevant? And before we do that, we need to just do a brief overview of Senceive systems as they currently stand. If any of you have spent any time in our webinars or on our website before, this graphic is probably familiar to you. Starting with our flat mesh system, our 2.4 gig mesh network, ideally suited for dense monitoring applications, faster reporting rates, high-end features like InfraGard, camera triggering, well suited to those dense monitoring environments. The GeoWAN side of things is our more sparsely populated, long-range, slower reporting solutions. We're getting distances from up to 15 kilometers between the node and the gateway devices. With both of these systems, there's ultimately the need for a backhaul solution to get that data from the nodes into your monitoring platform, whether that is Senceive IO, Web Monitor, or a third-party data visualization platform. That backend system is typically a gateway device that sits in the middle. In flat mesh, it is a cellular gateway, obviously requires a SIM card and being in range of a cellular network or cell tower. On the GeoWAN side of things, your options are a cellular interface or an Ethernet interface, so you could plumb into an existing network infrastructure on the customer site, for example. Flat mesh is quite self-sufficient from a power perspective. You can connect a solar panel or DC power supply. There's an internal battery, and that product is self-sufficient. GeoWAN gateway is typically a bit more power hungry and require mains power or a power over Ethernet supply. So when we start talking about a SATCOM solution, we ask the questions: what do we need and why do we need it? And this is generally for projects that have no cellular or networking infrastructure. So what options do you have if that infrastructure doesn't exist on site? And the same situation with no power. If there's no power, how are you going to get that gateway running? How are you going to get that backhaul from your nodes to your server-side software? There's also the situation where your assets are thousands of miles away and logistically and financially expensive to access. They might require multiple flights. You might be currently doing helicopter surveys or dispatching someone into the field once every 6 months. And those things are expensive, they can be a logistical nightmare. And what if you want data more regularly than that? And that is where our SATCOM solution slots right in. So if we remember that previous graphic that we had and we look at what's been replaced here, this covers our satellite solution at a very high level. It's currently only available on our GeoWAN platform, so ignore flat mesh at the moment. We're talking just GeoWAN sensors, but we are also talking all types of GeoWAN sensors. So that's tilt nodes, laser displacement sensors, potentially even a digital node if you had a need for that. It is a complete turnkey solution. So if we think of our SATCOM solution as everything inside of this pink box, it's a piece of equipment that you would purchase, you would install alongside your site, and everything you need is in there. The equipment in there is ultimately collecting data from your nodes and transmitting that data via the Inmarsat satellite network into some back-end services that ultimately end up with your data coming out in Senceive or Web Monitor. The overall goal of the solution is to minimize power consumption in the SATCOM's box, minimize data usage, and that ultimately allows us to maximize the battery life of the product, keep it running in the field as long as possible, keep your costs down as much as possible, and give us an overall maximum monitoring solution. So we've seen it at a graphical level, and now I guess let's jump into what the actual components of the satellite solution is. So this is a picture of all of the kit that comprises the SATCOM solution. We refer to this as a GeoWAN Satcom's bridge. The reason that we call it a bridge is because it is bridging the interface between your nodes in the field and ultimately your backend server, our Senceive's backend server. Every piece of equipment here is IP67 rated and temperature rated, and it's standard variant from -30 to +70 degrees. So really suitable to those harsh outdoor industrial type environments. All cabling is pre-wired, pre-terminated, so everything is well bundled together, making the installation process quite simple. There's enough slack on all of the cables to work out some placement logistics, make sure you've got the satellite terminal in the right place, make sure you've got some flexibility on aiming the solar panel, but ultimately it's a single piece of kit that gets bolted to a pole or a bit of bracketry on site. It's fully autonomous with solar power, so we've got an internal battery, external solar panel, and some power management solution inside the cabinet, and that takes care of all of your power needs, so automatic battery charging, battery state of charge monitoring, battery health, etc. And all of this equipment is currently globally certified, so it carries certifications to operate in the vast majority of countries where we see this product operating. Looking down the picture from top to bottom, made up of a GeoWAN antenna, nice omnidirectional. It typically would sit at a good vantage point in your site where it has good line of sight to all of the nodes. Your satellite terminal, which comes in two variants, we'll get into that a bit later. Your solar panel, which again is configurable per project. And then your cabinet, which contains your internal GeoWAN gateway, the power management solution, as well as the internal battery. So what we'll do now is just break down each of these components into the areas of interest, starting with the GeoWAN gateway. So a standard GeoWAN gateway is a relatively dumb device. It just receives data from any node in the area and forwards that data straight onto a server. So you can imagine if there's a lot of nodes in the area, that ends up being quite a high traffic, high data usage scenario. Our intelligent GeoWAN gateway is limited to 100 sensors and limited to a maximum reporting rate of 15 minutes. And that will depend on the quantity of sensors and the types of sensors you have installed. But we'll typically look at 100 sensors, maximum 15-minute reporting. That gateway is responsible for running a local network server, which allows all of the nodes to connect to that server and pass their information on, and then optimize that data for transmission over the satellite terminal. So instead of just passing the data over directly, the gateway can do a bit of storing, data optimization, trimming out any unnecessary metadata, compressing that data as much as possible. And that compression allows us to achieve a 90% reduction in data usage, which translates directly to a 90% reduction in data costs on the satellite terminal. The gateway is also responsible for maintaining the satellite connection itself. So when we need to use that connection, we can establish it, and when we're not using it, we can shut it down. And it's important to note here that we've already mentioned 100 sensor maximum and the fact that this is operating as a bridge device, which means it requires a bit of pre-configuration to get into that state. That's something that Senceive takes care of when we talk about linking nodes to gateways so that they can operate together. From a power perspective, this, unfortunately, is not a one-size-fits-all solution. It's very dependent on the geographical location of the project, the amount of sunlight that ultimately the asset will see, as well as the temperature profile that might exist on site. Those parameters ultimately guide us to choosing a specific size for a solar panel, as well as a specific capacity for the internal battery. And if there needs to be any temperature rating, perhaps you're operating the low temperature environment, you need a battery with some internal heating packs to maintain a steady temperature to get a healthy charge and a low discharge rate. The power solution also makes use of scheduling. What this allows us to do is, say for example, you have 20 nodes on site, they're running at 4-hour reporting. You can let those 20 nodes sample and send their data over. Let's say that whole process, just for easy numbers, takes 20 minutes. And you can then shut the equipment down for the rest of that 4-hour window, saving all of that power, ensuring there's no data usage happening. 4 hours later, the entire set of equipment will start up again, collect a set of measurements from the nodes, and transmit them. And through all of those things, through the nodes, through the reporting rates, through that scheduling, we can optimize the size of the panel, the size of the battery, the number of days of autonomy in case there is no sunlight, and ultimately deliver a solution that allows this project to be viable. Moving on to the satellite terminal itself, we make use of the Inmarsat satellite network. And this is a network of geostationary satellites. There are 4 of them. They sit in geostationary orbits over 4 different points in the Earth, and they give you this coverage map that pretty much covers everything that is between +70 and -70 degrees. So there's no coverage at the polar regions, but there is coverage for the vast majority of the planet, which is great. There are 2 flavors of terminals available. So there is the IDP, which is the iSat Data Pro. This is typically an extremely low data usage terminal. So if you had a handful of nodes at a slow reporting rate, we would recommend that you go with the IDP terminal. That'll keep the cost down and keep the data costs down. If you're running a slightly larger monitoring site or slightly more regular reporting rates, you would be on the BGAN M2M plan, which is this runs on this terminal we've got in the photo. On both plans, because these are geostationary satellites, your latency is in the order of minutes, which is well in line with structural monitoring requirements and the typical reporting rates that you would be running on site. So if you had 1-hour reporting and a 5-minute turnaround on data, that would be perfectly acceptable. Because these are geostationary satellites, there is a procedure that's required on installation, and that is to aim the satellite. It is extremely straightforward. There's a button on the back of the terminal to put the satellite into an aiming mode, and it begins to emit a tone. And as you sort of like a homing missile, you aim the terminal to where the satellite should be. That tone gets faster and faster until it becomes a steady beep. And that's when you know the satellite terminal is aimed. Tighten the bolts, and you're good to go. That installation is done. Now that we know the various bits and pieces that make up the SATCOMS project, let's talk about the information that we would need to make your next project a reality. The things that we would need from you are the number and the types of nodes. So by type, I mean crack sensor, tilt sensor, laser displacement sensor, and the required reporting rates that would allow us to draw up a sampling profile of when you need equipment to be active. Maybe you want tilt sensors operating at a fast reporting rate, crack sensors a bit slower, kind of thing. We can take that information, plan it into the scheduling. And then what becomes really significant for the project is the geographical location. And that should be as accurate as possible, because we need to take that information and convert it into a solar budget, as well as a potential temperature profile. And temperature would typically drive the choice of battery, and the solar profile in combination with that will drive the choice of battery plus size of solar panel. So we would work with you to discuss number of days autonomy, typical weather conditions on site. Is there potentially any snowfall that we need to be concerned about that might block the panel for a number of days? And all of that information comes together to feed into the power solution. So yeah, we get number of nodes, required reporting rates, geographical location from you, and that allows us to do a number of things. It's determine the satellite terminal and the data plan that would best fit the project. Also to spec out the solar panel, battery specifications, and that's with regards to the size, the capacity, the ratings, potentially any low temperature performance concerns that we need to take care of. We can also work through optimum power scheduling requirements. So if you want 6 hourly data, we can ensure that the equipment stays off for the bulk of that 6 hours and doesn't unnecessarily consume battery power. We would also go through node configurations, groupings, and optimizations. And the steps that we would take there are basically just to trim out as much unnecessary data as possible. So potentially turn off some unused data channels, space the nodes out so that they don't report at the same time. There's no radio collisions, there's no need for retries, and there's minimal risk for missing data points. When we are implementing a SATCOMS solution, it's important to note that that upfront planning is critical. And the main reasons for that is because, as I've said before, the GeoWAN nodes and the bridge need to be linked from the start. So that setup is relatively inflexible, probably the right way to put it. So we need to know quantity of nodes, parameters for all of those nodes, and we would link those nodes to a bridge so that that is the only communication that's flowing through the satellite. Changing the node configuration in the field is challenging. It's not impossible, but it is something that needs to be well thought out. You can't just send a command to say, I need 30-minute data. I'd like to change that to 1 hour data. I'd like to change the sweep frequency of this vibrating wire sensor. Again, it's important to plan this information up front so that we can set the equipment up like that from day one. Changing the power scheduling is not possible at all remotely. So as it stands at the moment, that is something that's set up manually when we scope a project, and it cannot be changed through any remote methods. It requires someone to have hands-on access to the equipment on site. In line with that, the battery and the solar panel are sized based on your requirements. So if you're doing an initial evaluation and you expect that project to expand, you would try and factor that in up front, potentially plan for a higher number of nodes, potentially even order a higher number of nodes and just keep them out of range of the satellite terminal so that they don't consume any unnecessary data. The point that we're trying to drive home here is that, yeah, that upfront planning is critical for your devices and for scoping out the size of the project. So let's say you now have a live project. Where do you get the data? And obviously there would be concerns that because this is a whole set of new equipment, there might be yet another methodology for accessing data. But what we tried to do at Senceive is always keep things within the same ecosystem. And the perks of that is that accessing your data is the same way that you've always accessed your data. It's either through Senceive IO or through Web Monitor. So you'll be familiar with your data reports, with your data alerts, with how to set up devices. There are no changes there. So we've taken care of all of the work to make sure that the data from a satellite terminal moves through those systems and comes out in the same way that any other project would. There is a slight disclaimer on this. It's that, and it's been mentioned before, it's that device management options are limited. So if any of you have worked with Senceive IO before, you'll be familiar with the interface that allows you to change reporting rates, change certain parameters of the sensors, send commands to the sensors. That in its current form doesn't work. And the reason is because we don't want devices to end up in a state where they consume too much satellite data, or even worse, blow through your entire data allowance in the first day of operation. So things are quite restricted there. and we would work together with you if you ever needed to make a change to something on site. Now let's have a quick look at a live site of ours that's in the field. So this is a photo of the satellite bridge installation. This is in equatorial Africa. We had an excellent solar radiation budget for this site. So with a combination of a 200-watt solar panel and a 12-volt 60-amp-hour battery, we end up with a set of equipment that is always on. There's no power scheduling, and the reason for that is because we have a bunch of nodes on here that are at 1 hour reporting, so there actually isn't enough time to switch the equipment off and switch it back on again. There's no need to. With an appropriately sized panel and battery, we can get around that issue. The satellite terminal itself, you'll see here, is pointing straight up to the sky, and that's because we're on the equator, we're in Central Africa. The closest Inmarsat satellite to that point would be directly overhead, so this was quite an easy one to aim. And having a look at the actual equipment that's on site from a monitoring perspective, so we are looking at structural monitoring of a railway bridge here. The satellite bridge is installed on one side and the monitoring radius is a few hundred meters. We have 39 of our low profile GeoWAN trackbed nodes on the site. You can see the low profile cap so that you're not at risk of knocking an antenna off. It's quite mechanically secure. And we have 6 laser displacement nodes dotted along the bridge, monitoring for any deformities of that bridge structure. Everything on here is at 1 hour reporting and distributed through that hour so that we don't get any collisions from nodes trying to transmit at the same time. To wrap things up, our GeoWAN Satcom solution allows you to monitor your most truly remote assets, even when power and communications infrastructure does not exist. We can support up to 100 GeoWAN nodes per bridge, as fast as 15-minute reporting, and latency in line with asset monitoring. Latency in line with expectations for an asset monitoring project running at an appropriate reporting rate. And to wrap up, your data would be available in Senceive or Web Monitor, so you can work with it as you please, consume it into your own systems, or stick with the Web Monitor environment that you're familiar with. And that's it from me. Thanks very much for attending, and happy to field any questions if there are any.
Wonderful. Thank you, Adam. That was really, really great and really exciting seeing those photos from that project in Africa. Really great. We do have a question that's come in already, and this is on the number of sensor nodes. So I know you mentioned a maximum of 100 sensor nodes. Someone's actually asked, what do I do if my monitoring project is larger than 100? Is there an option for me?
Yeah, so typically what we would do in that scenario is every time you exceed 100 nodes, you effectively need another satellite bridge because of that 100 maximum. What we would do in that scenario is definitely partition out the nodes into different areas, so they basically become their own mini monitoring projects. So that both, if you have 150 nodes, you would need 2 bridges, and we would optimize the use through both of those bridges to keep the ongoing costs as low as possible and keep the solar and the battery appropriately sized.
Right, yeah, makes sense. Okay, another question just come in about applications and what we think the applications are going to be that are the ones that are going to be most benefiting from this new option, this new solution.
Yeah, so in a nutshell, I mean, I know the tagline is quite far and wide. If there's no cellular infrastructure, no power infrastructure, this is a good solution for you. Where we've seen significant interest at the moment is from remote railway monitoring sites in northern Canada. Obviously, they're covering massive amounts of ground with no infrastructure along that route other than the railway itself. But there's been a lot of interest there for that monitoring. And we've also seen quite a bit of keen interest from the mining industry in Australia, where again, it's massive landscapes with nothing around, but there's an asset that you need to monitor. And at those large scales, it's perfectly suited to a GeoWAN style monitoring solution.
Great, thank you. What about flat mesh? Someone is asking, because currently this is just available on the GeoWAN platform, isn't it? So someone's asked about flat mesh and InfraGard specifically, if that is on the horizon.
Okay, it's definitely something that we've been considering as a company. It would make sense for us to offer a SATCOM solution on the flat mesh network. We don't have it yet, and a big driving factor of that is because there's so much potential on flat mesh to generate more data than expected. You know, you've got things like InfraGard with dynamic reporting rates. Ultimately, you have InfraGard because you want to be triggering cameras and taking photos of your assets, as well as just getting your sensor data. And that entire ecosystem can potentially produce a lot more data than a GeoWAN system. So until we have a way of managing and optimizing that higher volume of data, we're stuck with just recommending the GeoWAN solution over SATCOMs for now.
Makes sense. Okay. We do have a question on cost, which I don't know if you can touch on that. Rough cost basis for instrumentation and system setup.
We can definitely get one of the sales guys to get in touch with whoever's asked that question. I am afraid I don't have those numbers at hand.
Yeah, we can definitely, whoever's asked that, we can definitely get back to you. I think that's it on the questions, but of course, if you think of anything else, the email address is on the screen right here. It's info@senceive.com, and we will get back to you with any questions you have. The recording of this will be sent out very soon as well for anyone who's registered. And the last note is to keep an eye out for our June webinar. We will run a June webinar as well, so keep a lookout. So thank you so much, Adam, for your time, and thank you to everyone who joined us, and have a great rest of your day. Thank you.